Welcome students to the second module of chapter number 5 fractions. In this module, we will learn various methods to obtain the equivalent fraction for a given fraction. We will learn what is meant by like fractions and unlike fractions and various examples. We will also learn to convert the given unlike fractions into like fractions. Problem set 17. Question number 2. Find an equivalent fraction with denominator 18 for each of the following fractions. The first fraction given is 1 upon 2. So here we have the given fraction is 1 upon 2 and we have to find out its equivalent fraction having denominator 18. So let us find out the missing numerator. We have seen various methods of obtaining equivalent fraction of a given fraction in previous module. Let us compare the denominators of both the fractions. As here the denominator of the missing numerator is bigger than the other denominator, we have to apply the method of multiplication to get the answer. Here 18 is the multiple of 2. So let us find out a number which when multiplied by 2 gives 18. Yes, we have 2 multiplied by 9 is equal to 18. Since we are multiplying the denominator 2 by 9 to get the equivalent fraction with denominator 18, we also have to multiply the numerator 1 by same number, that is 9. So after multiplication we get 9 upon 18. So here is the missing numerator, that is 9. Hence we say 9 upon 18 is the equivalent fraction of 1 upon 2. Next question is find an equivalent fraction with denominator 5 for each of the following fractions. Here the given fraction is 6 upon 15. So as the given fraction is 6 upon 15 and we have to find out the fraction equivalent to this fraction with denominator 5. So let us find out the missing numerator. First, compare the denominators of both the fractions. Here, the denominator of the missing numerator is smaller than the other denominator 15 and 15 is multiple of 5. So, we have to find a number which when we divide 15 by that number gives 5. So we have 15 divided by 3 is equal to 5. So, we will get the number in the box also by dividing the numerator also by 3. So here we write 6 divided by 3 is equal to 2. So let us divide this fraction by 3. We get 6 divided by 3 is equal to 2 and 15 divided by 3 is equal to 5. So we get the missing numerator as 2. Therefore, the equivalent fraction of 6 upon 15 is 2 upon 5. Next question is, from the given fractions, pair of the equivalent fractions. Here some fractions are given in the box and we have to pair off the equivalent fractions. Let us take first fraction 2 upon 3. Compare it with the second fraction 5 upon 7. Now look at the numerators of these two fractions. Here 5 is not the multiple of 2. Therefore, these two are not the equivalent fractions. Next fraction is 5 upon 11. Here also, look at the numerators of both the fraction. You will find that 5 is not the multiple of 2. Therefore, these two fractions are also not equivalent. Let us compare the first fraction with the next, that is 7 upon 9. Look at the numerators. Here also 7 is not the multiple of 2. Hence, 2 upon 3 and 7 upon 9 are not the equivalent fractions. Next, we compare 2 upon 3 with the fraction 14 upon 18. Now here 14 is multiple of 2. 2 into 7 is equal to 14. Since we multiplied the numerator by 7, we also have to multiply the denominator of the fraction by same number, that is 7. After multiplication, we get 2 into 7 is equal to 14 and 3 into 7 is equal to 21. Now the obtained fraction is not equal to the given fraction. Therefore, we say 2 upon 3 and 14 upon 18 are not the equivalent fractions. Let us compare the other fractions. 5 upon 7 and 10 upon 14. Here 10 is the multiple of 5. 5 into 2 is equal to 10. As we multiplied 5, the numerator, by 2, we also have to multiply the denominator 7 also by the same number, that is 2. So, after multiplication, we get 10 upon 14, which is equal to the given fraction. Hence, we say 5 upon 7 and 10 upon 14 are the equivalent fractions. Next is 2 upon 3 and 15 upon 33. Now here 15 is not the multiple of 2. Hence, we say 2 upon 3 and 15 upon 33 are not the equivalent fractions. Next is 2 upon 3 and 18 upon 70. Here 18 is the multiple of 2. Therefore, we know that 2 into 9 is equal to 18. As we multiplied 2 the numerator by 9, we also have to multiply the denominator 3 also by same number, that is 9, and we get 18 upon 27 after multiplication, which is equal to the given fraction. Hence, we say 2 upon 3 and 18 upon 27 are the equivalent fractions. In this way, we have found that 2 upon 3 and 18 upon 27, 5 upon 7 and 10 upon 14, 5 upon 11 and 15 upon 33, 7 upon 9 and 14 upon 18 are the pair of equivalent fractions. Next question is, find two equivalent fractions for each of the following fraction. Given fraction is 7 upon 9 and we have to find two equivalent fractions for this fraction. We have learned that when we divide or multiply the numerator and the denominator of a fraction by same number, we get a fraction that is equivalent to the given fraction. So we have two methods to obtain equivalent fraction of given fraction. First method is by multiplication and the second method is by division. So let us find the equivalent fraction for the fraction 7 upon 9. Now here it is not possible to divide the numerator 7 and denominator 9 by same number. So we use method of multiplication here to find out the equivalent fractions of the fraction 7 upon 9. So let us multiply the fraction 7 upon 9 by 2 to get the equivalent fraction. So here we get 14 upon 18 as the equivalent fraction of 7 upon 9. Let us find out one more equivalent fraction of 7 upon 9. Now let us multiply this fraction by 3. So we get 21 upon 7 as the second equivalent fraction of 7 upon 9. So here we get 14 upon 18 and 21 upon 27 as the equivalent fractions of the fraction 7 upon 9. Let us learn about like fractions and unlike fractions. The fractions whose denominators are same or equal are called as like fractions. For example, 7 upon 9, 4 upon 9, 3 upon 9. Here you can see all these three fractions have same denominator, that is 9. Such fractions are called as like fractions. Let us know about unlike fractions. The fractions whose denominators are different are called as unlike fractions. For example, 7 upon 11, 3 upon 5, 8 upon 9. Here you can see all these three fractions have different denominator. Such fractions are called as unlike fractions. Problem set 18. Convert the given fraction into like fractions. First example, 3 upon 4 and 5 upon 8. So, as you can see here, these two fractions are unlike fractions because they have different denominators. And we have to convert these two fractions into like fractions, means we have to make their denominators same. Now, look at these denominators. As 8 is twice 4, it is easy to make 8 as a common denominator. So, to make the common denominator as 8, we have to multiply the first fraction 3 upon 4 by 2. And hence we get 6 upon 8. So our first fraction 3 upon 4 became as 6 upon 8. And our second fraction is 5 upon 8. So as you can see, here these two fractions have same denominator, that is 8. So 6 upon 8 and 5 upon 8 are the required like fractions. Let us solve one more example of this type. So here we have 3 upon 5 and 3 upon 7. These two are the unlike fractions, as you can see, and we have to convert these two fractions into like fractions. Now, here look at the denominators. 7 is not the multiple of 5. So in such case, in order to make the denominator same, we have to use the method of cross multiplication. So the product of the denominator can be made as the common denominator. So here 5 into 7, that is 35, can be taken as a common denominator. Now, in order to make 35 as a common denominator, we have to multiply the first fraction by the denominator of second fraction. That is, we have to multiply 3 upon 5 by 7. So, after multiplication, we get 21 upon 35 as the first fraction. Now, let us multiply the second fraction by the denominator of first fraction. So, we multiply 3 upon 7 by 5 and we get 15 upon 35 as the second fraction. So here we get 21 upon 35 and 15 upon 35 as the required like fractions.